Good morning, students. In this class, I want to solve some more problems on Fourier Sine Transform, students. What, students? Fourier Sine Transform. Let us see. Find the Fourier Sine Transform of e power minus modulus x. Hence, show that integral 0 to infinity x sine mx by 1 plus x square into dx, that is equal to pi by 2 e power minus m, where m is greater than 0. M is greater than 0, students. So, solution. What is function, students? E power minus modulus x. So, let f of x, that is equal to e power minus modulus x. Minus modulus x. We are finding here, students, Fourier Sine Transform. So, Fourier Sine Transform. Fourier Sine Transform of f of x is fs of s, that is equal to integral 0 to infinity f of x sine s x dx, sin s x dx, that is equal to integral 0 to infinity f of x, students, e power minus, say, students, 0 to infinity. So, modulus x value is positive. So, we can write x, students. So, e power minus x sin sx dx, sin sx dx. Now we have property, students. What is property? What is formula, students? Sorry. Integral e power ax sin bx dx, that is equal to e power ax by a square plus b square into a sin bx, minus b cos bx. What, students? B cos bx. Now, what is a here, students? What is a? A is minus 1 and b is, students, yes. B is yes. So, that is equal to e power ax. So, e power minus x by a square plus b square, minus 1 square. So, 1 plus b square, s square into a minus sin sx minus b, students, s cos sx, between limits 0 to infinity. That is equal to, substitute upper limit, students, e power minus infinity. So, value is 0 minus, substitute lower limit, students, e power 0 value is 1. So, 1 by 1 plus s square into sin 0, students, sin 0 0 minus s into cos 0 value is 1, students, cos 0 value is 1. So, that is equal to minus into minus plus s by 1 plus s square. Now, this is fs of s, students, fs of s. Now, say, students, what he mentioned, show that integral 0 to infinity x sin mx by 1 plus x square dx, that is equal to pi by 2 e power minus m. So, to evaluate such type of integration, we are always taking inverse Fourier Sine Transform. Okay, students? If it is a sine transform, we are taking inverse Fourier Sine Transform, students. If it is cosine transform, we are taking inverse Fourier Cosine Transform. If it is a Fourier Transform, students, we are taking inverse Fourier Transform. Are you got my point, students? Right. Inverse Fourier Transform. Inverse Fourier Sine Transform. Inverse Fourier Sine Transform. What is inverse Fourier Sine Transform, students? F of x, that is equal to 2 by pi integral 0 to infinity fs of s. What, students? Fs of s into sin sx. Come on, tell me, students, here. What, students? ds. Very good. It is ds, students. So to that is equal to 2 by pi integral 0 to infinity fs of s, students. Fs of s is s by 1 plus s square. So s by 1 plus s square into sin sx dx. This is f of x, students. F of x. Now I compare these two, students. Okay, students, I compare these two. So we have here m, students. So m. So put x is equal to m, students. Put x is equal to m. That means we get here f of m, that is equal to 2 by pi integral 0 to infinity s by 1 plus s square sin ms into, this is ds, students. ds into ds. Okay, students, f of m means f of m, students. That means e power minus modulus m, students. Since it is 0 to infinity, we can take e power minus m, students, for m greater than 0. We are considering m greater than 0, students. So 2 by pi, that is integral 0 to infinity s by 1 plus s square sin ms ds. Now you cross multiply the, students. I want to take s as, students, s as, very good, x. So put s is equal to x. We get here, students, integral 0 to infinity x by 1 plus x square into sin mx dx. That is equal, students, pi by 2 e power minus m, which is required solution of the given integration, students. Let us see another problem, students. Find Fourier Sine Transform of e power minus ax by x, students. E power minus ax by x. So solution, let f of x, that is equal to, or, students, e power minus ax by x, students. E power minus ax by x. Now Fourier Sine Transform, students. So write Fourier Sine Transform of f of x is what, students? Fs of s, that is equal to integral 0 to infinity f of x sin sx dx. What, students? Sin sx dx. So fs of s, that is equal to integral 0 to infinity f of x, students. What is f of x? E power minus ax by x into sin sx dx. I already told you, students, whenever we observe such type of functions like this, students, we first differentiate with respect to s. Or, students, differentiate with respect to s. So this is one. Differentiate 1 with respect to s. We get d by ds of fs of s, that is equal to integral 0 to infinity e power minus ax by x. Now see, students, this is dou by dou s of sin sx, students. Sin sx dx. I already told you, students, in previous classes, whenever you differentiate with respect to s, whenever you take the inside of the integration, the d becomes dou, students. The d become dou, because we have a formula, students. Right, integral 0 to infinity e power minus ax by x. How many times, students, here? Cos derivative of sin sx, cos sx into again derivative of x, students. Again derivative of x, sx. With respect to s, students, we get x. into dx. X cancel, students. X cancel. So again I have a formula, students. What is formula? Integral of e power ax cos bx dx, students. What is formula? E power ax by a square plus b square into a cos bx plus b sin bx. What, students? A cos bx plus b sin bx. Now what is a, students, here? What is a? A is minus a. And what is b, students? B is yes. B is yes. So that is equal to e power minus ax by a square, students. That means a square b square s square into a cos bx minus a cos sx plus b sin bx. So s sin sx between limits 0 to infinity. So that is equal to upper limit, students, e power minus infinity. So value is 0. Substitute lower limit, students, minus e power 0 1 by s square plus a square into cos 0, students. Cos 0 value is 1. So minus a. Sin 0 value is 0, students. 0. So that is equal to, we get here a by s square plus a square. This is d by ds of fs of s, students. Fs of s. But we don't want d by ds of fs of s value, students. We need fs of s. So integrate, students. Integrating with respect to, students, with respect to s, we get integral of d by ds of fs of s, that is equal to integral of a by s square plus a square into ds, students. ds. So here we get d by integration derivative cancel, students. We get here fs of s, that is equal to integral of a by s square plus a square, students. Generally we have 1 by a tan inverse s by a cancel, students. So we get here 1 tan inverse s by a plus c, students. Tan inverse s by a plus c. Okay, students, tan inverse s by a plus c. Now I want to find tan inverse c, students. Here I want to find c value, students. So put s is equal to 0. Whenever s is equal to 0, see, students, here s is equal to 0 here. Sin 0 value is 0. So fs of s value is 0. So that is equal to tan inverse 0, students. Tan inverse 0 also 0. So plus c. Finally c value is 0, students. Therefore fs of s value is, students, tan inverse s by a, students. Tan inverse of s by a Fourier Sine Transform is tan inverse s by a, students. Once again, students, a given function like e power minus ax by x, you simply differentiate with respect to s, students. We get, and apply some formulas, we get the, students, a by s square plus a square. This is d by ds, students. But we want to find fs of s, so integrating with respect to s, students, we get fs of s is equal to tan inverse s by a plus c. So I want to find c value, students. We are always finding arbitrary constant values. So put s is equal to 0. So 0 is equal to, we get, applying here, we get c value is equal to 0. Finally I got the Fourier Sine Transform of given function is tan inverse s by a. Okay, students, hope you understand. Thank you for watching this video. Jai Hind.